Welcome to our session, Opening the Doors to Machine Learning, How AAA Leverages BQML and Google Sheets to Predict Call Volume. My name is Sara Robinson. I'm a developer advocate on the Google Cloud team focused on machine learning. You can find me on Twitter at srobtweets. And later on in the presentation, we'll be hearing from Dr. Chuck Brooks, the Director of Data Strategy at AAA's Auto Club Group. And we'll also hear from Matt Powers, a senior consultant at Mavenwave. Mavenwave helped AAA implement their solution. Just a reminder that we are using Dory Q&A for this session. So if you have questions that come up as we're talking, just open up your Next app, add a question in the Dory, and we will do our best to answer it at the end. So what we're going to cover, I'm going to give a product overview of BQML and AppScript, which were both used in AAA's use case. Chuck is going to talk about what AAA's Auto Club Group does and how they're using BigQuery machine learning. And then Matt is going to do an end-to-end live demo of AAA's use case. Before we dive into BigQuery machine learning, let's talk a little bit about what BigQuery is. So BigQuery is our cloud data analytics warehouse. It lets you store and query lots and lots of data super fast. What do we mean by lots of data? Petabyte scale storage and queries. And you can do it all in familiar SQL. The great thing about BigQuery is that it's fully managed and serverless. So you don't have to worry about spinning up any of the infrastructure to run complex queries. BigQuery will handle all of that for you. So BigQuery is a great starting point for machine learning because you often need a lot of data to get started with machine learning. But if you haven't ever built a machine learning model before, that process can be daunting. There's a lot to learn. It's also expensive for companies to hire enough data scientists to build these machine learning models. And it's complex and time-consuming to take your data out of a data warehouse like BigQuery and feed it into your machine learning pipeline. So let's talk about the process of how we would build a custom machine learning model without BQML. We would first identify a problem that we would want to solve with machine learning and gather our data. Then we'd pre-process our data, so we'd want to get it into the right format for our machine learning model. So this means if we had categorical data, we would need to one-hot encode that into arrays. Then we would split our data. So an important concept in machine learning is train, test, split. So you take about 80% of your data, use that to train your model, and you set aside about 20% for testing to see how your model performs on data that it's never seen before. Then in step 4, you're actually writing the code to build your model, choosing your model architecture, and training and evaluating your model. You might repeat steps 4 and 5 a couple of times until you get accuracy that you're happy with. Then finally, you'll need to spin up infrastructure to deploy your model so that you can handle prediction requests from your users. The great thing about BQML is that it simplifies this a lot. So with BQML, all you need to do is identify a problem that you want to solve with machine learning, gather your data, write a query to train and evaluate your model, and then it's automatically available to get predictions. So just to summarize some really great features of BQML, it lets you execute ML models without moving your data from BigQuery. So you don't have to take your data out of the data warehouse and feed it into your ML pipeline. You can do it all right from BigQuery. You can iterate on your models in SQL, so it's really fast to train new models, try out different sets of features and labels. And BQML also automates common tasks like hyperparameter tuning and train test split, which I talked about before. So this is all of the SQL code you need to build and train your model. In this example, we're building a model to predict how many bikes are in circulation in New York, given some data on the weather for that day. So we tell it the type of model we want to use, the labels that we're using for the model, and then we tell it what table to grab the data from. And once this query finishes, we've got a trained model ready to go. Similarly, to generate predictions, you just call ml.predict. And when you run this, BQML will add a column called predicted underscore, and then whatever your label name, column name was. So there's some really awesome new and upcoming features in BQML that I want to highlight. Model evaluation charts are now available in the UI. So once your model trains, you get a little bit more insight into how that training process went and what evaluation looked like. K-means clustering models are in beta. And then we have a bunch of different alpha features here: matrix factorization, the ability to import TensorFlow models that you've already trained externally and query them in BQML, feature pre-processing functions, and TensorFlow DNN classifier and DNN regressor models. So if you want to try any of these out, talk to your sales reps or reach out to me and I can connect you to the right people. Just send me a DM on Twitter at srobtweets. So I never like to get too far into a presentation without showing some demos. So we're going to see some demos of 2 different types of BQML models. The first will be a regression model. A regression model just means that our model is predicting a numerical value. So we're going to see, given the weather, how many New York City city bikes are in circulation. And then for our classification model, I've got some data on different types of candy bars, because everyone loves candy. And we're going to see, given some data on a candy bar, is it chocolate or not? So let's go to the demo. So this is the BigQuery UI. Make it a little bit bigger. There we go. I've got some saved queries here. So the first query I'm going to run is a prediction query. And this is on my bike model. And so what this is going to do is it's going to query my bike model. And I've got a test table here with, I believe, just 4 examples of data that wasn't included in our training set. And we'll see if our model can get close to predicting the actual number of trips. So this is what the query looks like, very similar to what you saw on the slide. And I'm going to run that. And it's done. And we can now compare predicted num trips with actual number of trips. And we can see that it's pretty close here. So we get 20,000, 20,000, 12,000, 12,000. All those predictions are looking pretty good. So that was a prediction for a regression model. Now I'm going to show a prediction for our chocolate classification model. So let's take a look at the data. Here's our test data. And what this model is going to predict is whether or not it's chocolate. So 0 for not chocolate, 1 for chocolate. And so when we run this query, we'll see that the output is a little bit different than what we get in the regression model. So this is telling us the predicted class for each input. But we also get data on the probability that the particular input belongs to this class. So what this is telling us is that there is a 97% chance that this is a chocolate candy bar, and then 3% chance that it's not. Similarly, for this one, we get 93%. And then these two, it predicted both of these correctly as chocolate. So we get 99% confidence for this one and nearly 98% confidence for that one. So that is how you generate predictions on models in BQML. But I also want to show you how easy it is to train a new model in BQML. So I want to show you the query that we use to train that chocolate classification model. And I'm actually going to change this a little bit. So this was a classification problem. We're going to change this to a regression problem. So another item from our data set is the popularity of each candy bar as a percentage. In the data set, it's called win %. So we're going to change this, and all we need to do to change it to a regression model is change this model type to linear regression. We now need to collect our new label column, which is win %, and then we will change the labels to that. So I'm going to kick this off. It should take about a minute to run. But again, the great thing about what BQML is doing here is it's making this whole process a lot simpler. So it used to take weeks or maybe even months of doing all these steps of collecting your data, getting it into the right format, converting categorical data to arrays. Under the hood, BQML is taking care of all of that for you. So when our model finishes, we should be able to run a query very similar to the bike regression query that we saw here. And you saw how easy it is to develop models iteratively. So if I wanted to add new features, maybe switch my label, it's just a matter of changing a couple lines of SQL. I don't need to rebuild my model code from scratch. So BQML really simplifying a lot of these steps for us. And again, the query should finish in about a minute. There we go. So our model's created. We will go to our model, and we can see that this is what our model schema looks like. So we'll get this predicted win % value. And if we go back to our save queries, we will just modify this query slightly to query from our new model, which we called chocolate _%. And we'll add the win % field to it too. So we'll run this query and see how our model does at predicting candy popularity. So here we get the predicted percentage of 42. If we scroll over here, the actual was 39. We can compare the rest of them, 39, 35, and it looks pretty close across the board for our predicted and our actual. So there you can see how simple it is to generate predictions and also train new models in BQML. So if we could go back to the slides. So there's an endless number of possibilities of different model types that you could build in BigQuery machine learning. I'm not going to go into all of these on this slide, but you get the idea of how you could apply it across many different industries. And the other product that AAA used in their implementation is AppScript. And what is AppScript? AppScript is a serverless JavaScript runtime for G Suite automation. So it lets you really easily connect different Google products. It's entirely serverless, so the code editor lives in your browser, but the scripts run on Google servers. It's written in a language based on JavaScript, so if you know JavaScript, you're good to go getting started with AppScript. And it lets you automate tasks across different Google products. I really like this code snippet example. So what this is doing is in the first row, we're getting a row from a spreadsheet, which is an address. Then we're creating a static map of that address, and then emailing that map to somebody. So in just 5 lines of code, we connect Google Sheets, Google Maps, and Gmail. And you can also connect additional APIs using AppScript through what's called Advanced Google Services. So this is what we'll use to connect BigQuery in the demo from Matt that you'll see later on. So using the advanced services, you don't have to worry at all about authentication. So it's just as if you were using the regular BigQuery client library in your AppScript code. G Suite Addons allow developers to build mini applications that live alongside top G Suite apps. They're installable domain-wide, and we used add-ons in the demo that you'll see shortly to embed a tool within Google Sheets as a sidebar. So just to summarize the different use cases that we've seen with BQML so far, we've seen customers use BQML to simplify existing workflows. So take existing machine learning pipelines, custom pipelines, and then move those over to BQML. We've also seen BQML as a great entry point to machine learning. So for data analysts that might not have experience with ML, and their data is already in BigQuery, they can just write some SQL queries to get started training custom machine learning models. And then we've also seen it used to complement existing machine learning workflows. So let's say you have a custom machine learning pipeline, but you've got a new idea, and you want to test it out to see if it'll work, to see if there's a relationship between a specific set of features and labels. So we've seen a bunch of customers using BQML so far. And I'm really excited to introduce Dr. Chuck Brooks, the Director of Data Strategy at AAA's Auto Club Group, to tell us more about their use case. Take it away, Chuck.
Thank you, Sarah. I am Dr. Chuck Brooks, and I am from the Auto Club Group. How many folks know of AAA? Oh, yeah. How many AAA members do we have? Even better. That's what I'm talking about. OK. So for you that know about us, you probably know about our roadside services. Certainly, if you're a member, you know about our roadside services. It's a pretty common service that we offer. But perhaps you didn't know that we really have 12 lines of business, and many of them have nothing to do with roadside. So we offer a full travel agency. Perhaps you didn't know that we have a full bank, that we offer life insurance and full line of insurance products, including home and auto. And in many of the states that we service, we do car repairs, so automotive repair services as well. What do these all have in common? Well, for us, it's all about the customer, right? It's all about offering services to our customer that enrich their experience and their lives and the things that they have to do every day. It's all about handling those tough situations, right? I mean, when your car is broken down on the side of the road, or you get up in the morning and you go out to start the car and it doesn't start, you need some help, and we want to be there for you. So when our customers call, it's important that we be there to answer the phone. Of course, we're doing digital transformation like many folks, and you can do a lot more on your phone or with a text or on our mobile app. But when you reach out, we need to be there for you. And so when I joined AAA just some short 10 months ago, we needed to bring the data together from all of those lines of business. Like many companies, our data was siloed inside of each one of the lines of business, and in fact, the different lines of business and the data there couldn't talk to each other. Have you experienced that before in your organizations? Would you be surprised if I told you that the banking customers, the banking organization didn't know who our 10 million members were? I was, and I've seen this, right? I've been doing this for almost 40 years, and I've seen silos of data, but we had taken it to a whole new level. So we began to build a data lake, and we began to use GCP products to do that, primarily BigQuery, but the rest of the data stores as well. And we began to move our data in, and we began to integrate it, and we began to put it in formats where it was usable, where analysts could look at it, and they could understand what was happening across our organization. But as we did that, one of the things that I noticed was that we hadn't made it easy for analysts who weren't SQL developers to necessarily get to that data. And so I looked across the GCP platform and I said, well, what can we use? What tools can we bring into play that allow analysts who aren't necessarily SQL developers to be more effective in our environment? And I thought, BigQuery, Google Sheets, because everybody knows spreadsheets. Analysts love spreadsheets. And BQML. And I said, how can we bring these together to begin to predict how many call center agents we need to have available at any given time so that when our customers call, we can be there? And so I reached out to one of our trusted partners. I hope you guys know the folks from Maven Wave. We work with them regularly. They do some great work with us. They don't try to do the work for us. They like to work with us. And if you're working with partners, you know how important that is. So let me introduce Matt, and Matt can show you a little bit about the application that we've created. It's been sanitized a little bit, but you'll get the idea.
Well, thank you, Dr. Chuck Brooks. That was a great intro. So yeah, Maven Wave is a Google Premier partner. On the right-hand side here, we've got the different ways that Maven Wave's broken down its different practices. And it's actually pretty closely aligned with the different Google products that are out there. So data analytics, something I'll be focusing on today, things like BigQuery ML and all the other great machine learning tools and capabilities that Google has, and everything from enterprise collaboration, so helping companies integrate G Suite into their environments. So again, thank you, Dr. Chuck Brooks. So now focusing on the problem. So as Chuck mentioned, answering the call, being able to answer the call at the different call centers is crucial to AAA. Being there when someone calls when they're in an accident or their vehicle, flat tire, whatever it may be, they need to be there to answer the call. So that was really crucial for this use case. So we've got some of the KPIs for AAA call centers, things like the customer experience, the agent utilization, the cost, and all of these things can be tied back to, is an agent in the call center? Do they have the right staff for this call center? So with that in mind, the problem that we're trying to solve is, how can we always make sure that someone is there in the call center to answer the call? So with that being the problem, what was the solution? And Chuck and Sarah have both hit on this, but we wanted to make it very easily to run a lot of different scenarios to be able to predict what that call demand was going to be. So we built a model using BQML, as Sarah walked through. We then wanted to expose the model to users throughout the organization in a very easy to use way. And we did that through Google Sheets and the Google Sheets add-on. And again, by doing this, it's allowed users with little to no ML experience to really utilize the power of machine learning to run these different what-if scenarios. So the end result, before kind of jumping into the demo here, so we created a BQML model. We integrated that into Google Sheets, and then that integration was possible through AppScript. Other last note here is 2 weeks of development time. So these tools, because we're using both GCP and G Suite, the integration between these two was fairly simple, and pretty quick development time to get to a good minimum viable product. So with that, I'd like to turn over a demo. Great. So We've got a Google Sheet. Most people are going to be familiar, most users at AAA are going to be familiar with this type of experience. You don't need any SQL skills to kind of navigate your way around here. So we've got a few different inputs that went into our model. So we've got things like state, county, month, what's the member segment? Because AAA doesn't want to just predict the call volume of a county. They want to predict the call volume of a specific member segment. We've also got things like population and the per capita income during that year. And then finally, the member count in that community and in that member segment. So what we've done here is we've created two what-if scenarios. So we said, what if per capita income goes up for the Florida Bay County? And then the second one, we looked at, what if the member count increases by 10% every single year? How's that going to change the call volume for that call center? And then, from that, what sort of hiring decisions does AAA need to make in order to staff that properly? So we've got our two what-if scenarios, and what I've done up here is just, as Sarah was mentioning, this is a Google Sheets add-on. So again, this was created all through Google Apps Script. What I'll do is I'll highlight all of the things that go into the model, so the X range, and then I'll tell BQML where I want the output to display. So I hit run model there. And what it did behind the scenes is we created a model in BQML, and then we're now surfacing the results. So we gave it the input data, and now we're surfacing the results in column I here. So we can see that for the first scenario, as per capita income goes up, it looks like the predicted call volume will go up slightly. For the next one, if the member count increases by 10% every year, there will be some substantial growth in the predicted call volume for AAA. So that at a high level is the demo, and it just highlighting all the different what-if scenarios that an analyst can now play. They could change the state, change the county, change the member segment. What happens if the population decreases? So a bunch of what-if scenarios that are can be utilized by anyone in AAA. So now jumping back to the slides. So kind of a few more. Diving a little bit deeper into what problems does this solve and how does this help AAA? So machine learning is becoming easier and easier to use. Now that you've opened up to spreadsheets, the users that have the ability to interact with a spreadsheet is obviously greater than the users that have SQL skills or even specific machine learning and Python skills. So greater adoption is definitely possible using something like this through Google Sheet. Now, kind of talking about the model delivery cycle. So here's the typical ML process. You start with the business objective, and then all the things highlighted in blue are areas where BQML can really help you with the full model lifecycle process. The first two there, the exploring and data selection, and then the pre-processing. Most of the time in machine learning work, that's 70% of the challenge and 70% of where the time's spent is getting the right amount of data, getting enough of it, making sure you do that exploratory data analysis, you find what features are important, and then the pre-processing. So BQML can't solve all these problems, but it does do a few key things to help you with this process. So the explore and data selection. So in the example I just showed, per capita income and population, I was actually able to get that through BigQuery's public data sets. They've curated a great public data sets, everything from census data to weather data, all sorts of great information. And the ability to now join that open source data set into your model is just a SQL join. You don't need to go out and buy any sort of data set, it's just a SQL join. So that was the first thing. As far as the exploration, it was all done through a SQL interface, which is fairly easy. And then they've also got a bunch of other great tools, things like Data Prep and Data Studio to do that data visualization and that exploratory data analysis, which is so important for machine learning problems. Then the pre-processing, so some great things that it handles behind the scenes for you. So one-hot encoding, so for those of you who are familiar with machine learning, if you have any categorical features like the state or the county, then you need to convert that into some array, as Sarah was talking about. So essentially rows of zeros and ones. That's all done for you automatically behind the scenes with BigQuery, so it can handle categorical features. And then it handles missing data. So if you have any missing data, there's ways that you can set how you want it to handle it, but out of the box, it'll put the median value in there for you. So just, it won't solve, all the pre-processing and data selection steps, but there's a lot of great things that make that process easier in the Google ecosystem and with BQML. And then the rest of the cycle, BQML can handle a lot of this. So model selection, Sara hit on, they're coming out with more and more models every day. And then the train, evaluate, tune, predict, and serve, that is all done through BQML. So now we've created this model, we've exposed it in Google Sheets. How do you actually deploy this in an organization? And that's kind of what this slide is getting at here. So we've got our data scientists and data analysts building these models in BQML. They've built model A, B, and C for predicting call volume, predicting where accidents are going to happen, all these different things that you can predict. Now I want to expose this to the organization. So we have the Google Sheet on the right, and really the only thing you need to do to expose that model to your organization is you need to give a user who wants to use the model access to the underlying data set and the model inside of BigQuery. So it's as simple as provisioning a user access to that model and that data set. And then users throughout the organization can utilize this. The last step and the kind of areas that we know as AAA and the Maven Way partnership we need to grow this is giving users better insights into how the model's performing. So we're just giving them the output, but what's the accuracy? Give users the confidence interval that the predicted call volume is going to be between X and Y. So instead of just kind of giving them a black box, here's the answer, giving them more insight into how accurate is this. So it's not just used blindly. So that's an area that we're working on and figuring out the best way to expose that to users who again aren't as familiar with BigQuery machine learning. So with that, I'm going to turn over to Chuck to talk about some of the value they've seen so far at AAA.
Thanks, Matt.
Yeah.
So was that cool? Is that cool stuff? I mean, these guys do a great job of presenting that. That's great stuff, right? Let me ask you, do you think folks in your organization, analysts in your organization, can use these tools? Probably, yeah? Okay, good. Look, we've got 3,000 agents across 5 call centers handling over 15 million calls a year, and I got to tell you that this is working for us. Early MVP results show that we can begin to reduce call times because we're accurately able to put the right staff in place on a regular basis. Now that's huge for us for all of the reasons that I mentioned. When our customers call, we need to be there.